So we are still on sheet 9. Advancing now to question 5. Let the function f of x be equal to 1/4 x to the power 4 minus 8x. Use the first derivative test to find any relative extrema of the function. Then use your graph to verify your answers. Use the first derivative. So the first thing you do is to get the first derivative. So the first derivative here is equal to x to the power 3 minus 8 using power rule. I guess that is okay with everybody. And then use it to find any relative extrema of the function. So how do we use it? We get the critical numbers and use the table test. That is the first derivative test. So we equate this thing to 0. So we'll have to solve this equal to 0. That is x to the power 3 minus 8 is equal to 0. Since x to the power 3 is equal to 8. So x should be 2. And then we quickly use a table. So we'll have 2 here. A number less than 2 could be 0. Bigger than 2, 3. And then the first derivative, x3 minus 8. So you use 0 here, you get negative. Use 3, we get positive. So what we are saying is that this guy is decreasing all the way up to 2 and start increasing after 2. Meaning that the value x taken in the original function, the value x is not 3, the value x is 2. Taken in the original function, we'll have 1/4, 2 to the power 4, minus 8 by 2. That is 1/4, 2 to the power 4, that is 16, minus 16. But 4 into 16 goes 4 times, so we get negative 12. So we have the relative extrema is not the value of x, but the value of f of x. Just like when we are looking at quadratic functions, when they say find the maximum value, what was the maximum value was not the x value, but the y value. So if they said find the relative extrema points, you include x. Find the relative extrema, we just give this number. So we are saying f of x is equal to negative 12 is a relative minima. The graph will help us know whether it's relative or it's the minimum value. When we say relative, we mean you could have this figure here and you still have some other numbers down.
Sir, I can't see your screen.
So let me see. I've been forgotten whether when I stop sharing I'll lose the screen or I won't. Do I lose the screen when I stop sharing and share again? Me too, I can't say. Okay, sorry, I mean, so let's see. I stop sharing. I come back.
And so if you can just start over, because some of us touch work one.
If you were theory choir, you would have immediately known that I'm choir and communicative. Anyway. Are you able to see it now?
No.
Yes.
Yes.
Now I'm able to see it.
Yeah, okay, there's one who can't. So let's try again. Okay, so I've tried twice. Are we now able to see?
Yes, sir.
Yes, sir.
Okay. So I just run through for those who were unable to see the screen. So this question is almost similar to what we are doing in question 4, except that here we are being asked to find the relative extrema and then verify our answer on the sketch. Now, to find the relative extrema, we need to run through the critical numbers. So this is our function. To find the critical numbers, we find the first derivative and get its zeros. So the first derivative equated to 0, we have x is equal to 2. Now when x is 2, to know whether our numbers are minimum or maximum, relative minima or relative maxima, we test using a table, just like we were doing. So when we test here, we have found a negative and a positive here. When we have negative, it means that the function f of x decreases in this interval and increases in the other interval. Now, I made mention that if the function was decreasing and then it starts increasing, this value here will be called the relative minima. Now we say relative minima if when we sketch, the graph comes out this way. This is the point, and yet the graph would still come down and bypass the point. So we still have numbers that are lesser than this value. Then we would maintain the relative minima. But if when we sketch, we obtain a sketch of this nature, then we won't say relative minima, we'll just say it's the minimum value. So it will be the extreme value. So now let's go for the sketch. To sketch this function, we need to get the x-intercepts and the y-intercept. Now, if you look at x, for its intercepts, we equate it to 0, minus 8x equals 0, 1 over 4, x minus 8 equal to 0. So we have 0 as an intercept. The intercept will come from 1 over 4, x3 minus 8 is equal to 0. Check this the other side. We have 1 over 4, x3 is equal to 8, multiplied by 4. We have x3 is equal to 32. So we're ready for the cube root of 32 is another intercept. And then at 2, we have negative 12 as the minimum value. So we only have 2 intercepts and 1 turning point, meaning that our graph will be of this nature. And so f of x is equal to negative 12 is the minimum value. Minimum, when I say minimum, it's the same as extra. Minimum value.
I can't see your screen. Now I can see.
Now you can see.
Yes, sir.
So it's your network, cash. Okay. So this question was a very nice one because it's just as one piece. Nothing like babies. So we move to question 6.
So before you move on,
Okay.
just for clarity, when you're finding you only apply the plus or minus when you're using the square root. So for the cube root, just take it as it is it?
Exactly. The cube root does not have plus or minus. A good example. What's the cube root of negative 27?
-3.
It is negative 3. If we made a mistake and said it's plus or minus 3, when you take 3 to the power 3, you get positive 27, which is different from negative 27. Okay, so we move to question 6. Question 6, let f of x be equal to x plus cos x. Find endpoints of inflection of the function in the interval 0 less or equal to x less or equal to 2 pi. Now you guys solved question 3. Yes, which was asking for the points of inflection. So I'm sure you remember that the points of inflection has everything to do with the second derivative. So we get the first derivative for the purpose of getting the second derivative. So the first derivative is 1 minus sin x. And then you got the second derivative. The second derivative is negative cos x. And then equate it to 0. So for this guy, it's equal to 0. So we have negative cos x is equal to 0. In this interval, cos is 0 twice. It is 0 at x is equal to 90, but 90 in radians is the same as pi multiplied by pi over 180, which is pi over 2. So I'm doing this deliberately so that in case you wanted to forget, we lock you here, no forgetting. The other one is at 270. 270 we can take it to radian. So it will be pi, 3 pi over 2. Now these are the values of x. But for the full inflection points, a point is x comma y. So you get your x and you go to f of x. So for x is equal to pi over 2, we'll have pi over 2 plus cos pi over 2. Now I said cos 90 is 0, so we just get pi over 2. So the first point is pi over 2, comma pi over 2. And then the second point will be 3 pi over 2, comma 3 pi over 2. Because cos 3 pi over 2 will again be 0. Any questions? Again, contributions. This is a tutorial, so we can contribute, we can subtract, we can suggest, we can ask, we can chat.
Yeah.
Hello.
Why is it 3 pi over 2, comma 3 pi over 2?
So because when we go to our original function and substitute 3 pi over 2, where there is x, we'll have 3 pi over 2 plus cos 3 pi over 2. But cos 3 pi over 2 is 0. So we still remain with just 3 pi over 2. Why is cos 3 pi over 2 0? How do you know that cos 3 pi over 2 is 0? Okay, these are special angles, so we don't need to worry. So that was question 6. We can move to question 7. Isn't it supposed?
The previous screen.
Sorry, sir. Sorry, sir, I've just joined. What tutorial are we doing?
So we're looking at sheet 9, Math 1120, written assignment 9. This was question 5, and we are just from doing question 6. Why is it negative sign and not positive sign? The derivative of cos is negative sign. And so moving from f to f prime, we are differentiating. Okay. You can now allow me to move to question 7.
Now, before you proceed, this same question, how do you know if when answering it, how do you know that you're supposed to differentiate twice?
The word inflection. Inflection does not deal with the first derivative. It deals with the second derivative. Just like we say critical numbers for the first derivative, for the second derivative, we say inflection points. Can I move? Or if you have questions, feel free to ask. Remember, we don't count, we only have September and October.
So, what happened after it differentiated twice there?
We equated to 0, what we got. The zeros of the second derivative form the inflection points. Okay. So question 7. Find the second derivative of the function a y is equal to 2x squared plus sine 2x. I just remind you that chain rule tells us that if you are differentiating u squared, the derivative here is going to be 2u multiplied by u prime. So if I'm differentiating u to the power n, the derivative here is going to be n u n minus 1 multiplied by u prime. So that if I'm differentiating sine u, the derivative here is going to be the derivative of sine, which is cos u multiplied by the derivative of u. That was just a quick reminder so that when we come here for the first derivative, using power rule for 2x squared, we'll have 4x plus the derivative of sine is cosine. We fix the 2x. Derivative of 2x is 2. So this forms our first derivative. Our second derivative, derivative of 4x is 4 minus, because of cos, derivative of cos is negative sine 2x. Derivative of 2x is 2, then 2 times that 2 there, we get 4. So our solution is 4 minus 4 sine 2x. That's the second derivative. B, y is equal to cot x. The good news is that cot is just cosine over sine x. So to differentiate this guy, we can use quotient rule where we let u to be cos x. Its derivative is just negative sine x. We let v to be sine x. Its derivative is just cosine x. So we'll have u prime v, which is negative sine squared x, minus v prime u, which is cos squared x, over v squared sine squared x. And this guy is the same as negative sine squared x plus cos squared x over sine squared x. And we know that sine squared x plus cos squared x is 1 over sine squared x. This is the same as negative cosec squared x. This is our first derivative. So our second derivative is the derivative of negative cosec squared x. So what's the derivative of cosec? If y is equal to cosec, what is the derivative of cosec? To avoid memorizing, we know this is 1 over sine x. So if we are to use you can choose to write this as sine x to the power negative 1. So that if we differentiate using power rule, we'll have negative sine x to the power negative 2 multiplied by derivative of sine, which is cos x. So we'll write it as cos x negative over sine squared x. So this is the same as negative cosec x cot x. As the derivative of cosec, so that when we differentiate here, the 2 there brings in a chain rule. So we'll have negative 2 cosec x multiplied by the derivative of cosec, which is negative cosec x multiplied by cot x. This is equal to positive 2 cot x.
Excuse me, sir, before you finish.
Okay.
Where is the negative 2 in front coming from?
So since we have negative, now this is negative cosec x. If we want, we can write it in this form. So when differentiating, the first thing to deal with is this 2. Using power rule, the 2 will drop down and then subtract a 1 from it to remain 1. So that's where the 2 is coming from, because we are differentiating this thing here. So that you guys can do C and D. So do we have questions? Okay, no questions. What if you know the derivatives by heart? You use your heart.
So I just want to ask you, here where you had to let u to be equal to cos x, I'm behind here, the network trip. Kindly repeat there on top. On the second derivative of the same function we are differentiating.
On the second derivative, we are not using these. We are using this. So we just first reminded ourselves as to what this derivative, what's the derivative of cosec. And then, so we are reminding ourselves what the derivative of this guy is. So that if we know it by heart, no need of reminding ourselves. You just pick it as it is because you know it. The same thing for cot. If I know the derivative of cot as negative cosec squared, I will just say y prime is negative cosec squared. The derivative of negative cosec squared, because I know the derivative of cosec, I'll easily use chain rule, and I'm done. I've answered the by heart question, and I hope I've answered the letting you for a second derivative. Okay, so we can relax a bit now. This was the second session. So this is 1913. We can break off up to 1925. We'll start. So since the link is already in the group, there's no reminder. At 1925, you just tap the link, you join, we start.